So here's what we're gonna do. I'm gonna try and do like a little case study of a part. This is a part that we're making for the project, and I can't tell you what the project is, but maybe I will in a later video. Like and subscribe, like and subscribe. Okay, so this is a part. It's going to be made of 6061 aluminum, and I'm just going to talk about my thought process. I'm self-taught, so I'm learning. So, you know, if I'm doing something totally stupid, let me know in the comments. I'd appreciate it. It's gonna be a simple hinged part, right? So there's gonna be a part like that goes through it, and then there'll be a pin, and then this will be the part of a hinge clevis. I'm making like 6 of these, and it's just like quick and dirty to test this prototype out. This should definitely not be made on a vertical mill in production. I'm making it on a vertical mill because that's what I have. I have 4th axis rotary platters on both of my mills, or both of my big mills, but I'm still not quite at the point where it's easy to set them up and program with them. So it would probably make the most sense to like hold this in a chuck on the rotary, and then cut out this thing, and then turn it, cut here, and then turn it and cut there, and do that all in one operation. I will probably mill a soft jaw for it that will grab on this, and then I will walk around this outside. I'll basically cut this whole profile. I will cut this slot, but I won't cut these countersinks. And then I have a long key seat cutter that I borrowed that'll cut that O-ring groove. After I do that, I will flip this up and I will clamp onto the machined part like so. And I will cut the bottom piece, I'll cut the outside to diameter, and I'll cut this little well into it. And then I'll set up a 3rd and 4th op that'll just be quick, just to cut the hole, and then flip it over, cut the hole in the counter bore, and then this will be done. So I'll try and film like each portion of it, and maybe the cam. So here's the assembly. I like to model everything just kind of as realistically as possible, with quite a few obvious exceptions. First obvious exception is that I only have 2 vices on the machine right now, so I tend to work left to right to just kind of do op 1, op 2, op 3, op 4, and if there's 8 ops to a part, I'll have an assembly that has all this kind of spread out in a line. But the thing I like about this is I can pretty easily go back in, hide something, and kind of show what is realistic. So now here's op 1 and op 2, and this is how I was running. So hop over to the other side. So this is SolidWorks 2018. And I'm using HSMWorks 2018. So op 1 makes sense to do as much work as possible in the first op. And again, we're doing this in a traditional 3-axis way. We're not using the 4th axis, even though it could be argued that it would be smarter, and it probably is. So I'm gonna start out by taking a face mill, taking my stock, and taking it most of the way down. I'm gonna leave about 10,000ths here so that I can come back and surface these because of tools in my mill. Then I'm gonna come with a big 3/4 guy and hog out most of this material, and then I'm gonna use the 3/4 finisher to kind of do a contour walking around, and then do a contour walking down on the inside, and cleaning up the floor, then using the bull nose on the contour mill to get this little fillet in here, and then doing it again one more time, just a spring pass, clean up. And then I like to do a bore operation to walk around the outside to get a decent, even finish, whereas something more like this leaves stair steps a little more. So then taking a 1/4-inch ball mill that was in the machine, surfacing all this top surface and those 2 fillets on the top, chamfering the outside, and then using this goofy key seat cutter a bunch of times to cut this groove for the O-ring. What I usually like to do with a prototype, I'm gonna set up op 1 and get those running and kind of tweak whatever I can and test it in the machine. And then I'll usually go program op 2. There's a ton of surfacing and a ton of stuff that you would not do in production whatsoever, but I've got a bunch of tools already loaded in the mill that I'm using for a bunch of other parts, so I'm just kind of being efficient. Being lazy / efficient. And we're gonna load this in the machine and then hit go. Oh, okay. There we go. So that's op 1. All we have to do is flip it over and take our stock off and create this pocket geometry in op 2. Here we're using some of the same tools, but this is a 1/2 inch rougher, 1 5/8 length. So that's kind of walking around the outside, cleaning up the puck. So you can see that it's showing that there's material here, but there's not really. Of course, the soft jaws are holding that 1/4 inch guide just to get a little deeper in this little well. And then the same 1/4 inch ball end mill that's doing a spiral operation that's just kind of zipping around on the inside of that inverted dome and cleaning that whole inside part up. I feel like if you look at it funny, it starts to go haywire. So anyway, after that 1/4 inch end mill, then it's coming all this junk in here. This is just graphic failures. That's stupid. But then I'm using this double angle chamfer mill to get the chamfer here and on the bottom side. So then op 1 and 2 are done. All right, guys, check it out. So I ran this op 2 already just to try it out, but what I did, some soft jaws that we had already cut down this block, just manually buzzed it down just so it fits in here just perfect. Gonna be setting that guy there. Okay. In the actual part, there's no hole, but in this part, I drilled a hole on purpose in this op 1, just so that I could touch on the floor that this is touching off of, and then I could probe inside that hole so that that second half has something from the first operation to go from. I've got all the op 1s and 2s cut, so you'll see that they don't have any of these holes in them yet, and that's what we need to finish out the part. Whoop. I need something, this part is completely round, but I need something to reference, to orient it so that I can drill perpendicular and it's clocked and it's referenced off of one of these flat faces. So what I'm gonna do, I just cut down a piece of 3/4 inch stock I found in the scrap bin. We've got a couple 1, 2, 3 blocks. We're gonna set those up like nya, and those will get bolted, or those will get set there. Then we'll put those in the vise like so. We'll get everything set up. We'll probably have to probe each one. We'll get this counterbore, that hole will go all the way through, and then we'll use the same setup, and we'll flip her around, and then we'll just finish that last counterbore, and then we should be good to go. Let's show up 3 and 4, which are going to be done in the same setup, but I just set them up, the models up twice so that I could get a work coordinate system here and a work coordinate system there. All right, let's set this guy up. let's give her a whirl. Alright, so we got this. We're going to have to hand deburr that, but that's not too big of a deal. Yeah, looks good. So let's go ahead and flip this over. And for this guy, it's the same height, so I'm not going to retouch off my Z. And I've got a nice bore there that's reamed out. I'll leave my Z alone. And then it's just going to reset the coordinate system for this operation to be right in the center of that bore. So that's going to line up perfect. And then this one doesn't have to drill through, so I'm not really worried about it going blah, 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 and chewing up that plate we have. I don't know how that's going to last, but let's give this a go. Alright. So, like I said, I'm going to have to deburr this, each one of these, but there's only a few of them, so I'm not too worried about that. And I think that's pretty good. This is the mating part that I made previously for it, so as you can see, and a 3/4 inch pin, slightly undersized, is for that. So really that's all this guy is going to do. It's going to go 90 degrees down and 90 degrees up, and you know, I still got to spec all this out to make sure the hole's in the right spot and that I can do it correctly each time. But from a first glance, that looks pretty good. All right, man. All right, guys. All right, everybody. Whatever. So that's about it. That's hopefully you enjoyed this first little story I'm attempting to do. Hopefully I can do more things like this in the future and get better at it so it doesn't take so much out of the actual process. Hopefully you learned something. Let me know if you know something I don't, have a question, tell me, say hi, let me know. Of course, there's 100 things we could do different and a lot of things we could do to get better. Always learning, and enjoy taking something from digital tofu to a plastic print to a real thing. So in this particular project that this is a part of, this is one part of maybe 25 unique parts that all need their own separate work holding, setup, all that. Hopefully we can do more of it and show you some other things and kind of learn along together. And yeah, I think that's all. Thank you for watching. Hit subscribe, do the thing. Blah, 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 blah. See you later. Hope you're well. Oh yeah, one more thing. Check this out. A little bit of an update for this week. So look how it's dark out there except for the robots doing my bidding. Focus, good. Shop, 1, 2, 3. And Eric said, let there be light. Ooh, whoa, and it was good. Check it out. So we've got 8 of these big ass lights now, and man are they bright, and they were expensive, but it's like freaking July daytime in here now, and it's pretty cool. Woo! And the other thing that's cool, I guess the last thing, is that I don't have to walk around and do extension cords anymore. Now we can just boop,